and resolution pairs, also known as bitrate ladder. And clients, based on their network condition and also device type, select the most appropriate bitrate resolution pair, and they watch the video. By extracting some features from the source video, we can answer some questions, such as where to encode, what bitrate ladder to select, and what encoding parameters to set. The state-of-the-art spatial and temporal complexity feature is SITI, but the observation is that time taking to compute SITI feature is quite high. For a 4K video, it is approximately 5 frames per second. It means that we can only extract features for 5 frames for a 4K video, which means that it's not suitable for live applications because it introduces additional latency. Also in VOD applications, it will bring us the higher computational cost. In addition to high time complexity, the correlation with encoding bitrate, also encoding time, is low for SI and T. So what is the solution? Motivated by this observation, we introduce video complexity analyzer, or VCA, that can be realized as a fast preprocessor, can determine the spatial and temporal complexity of video segments to aid the encoding process. So actually our main contribution here is extracting some new features. So what features we are extracting? For spatial complexity feature for a video sequence for frame number P, we split this frame into smaller blocks, block sizes W cross W, and for block number K, we calculate its DCT values, and then we introduce energy function for H as weighted DCT values. Just to calculate this energy function, we remove the DC or brightness of that block. So by averaging this energy function in entire frame, so we can calculate the spatial complexity feature. For temporal complexity feature for frame P, we consider frame P itself and its previous frame. So we calculate sum of absolute differences between co-located blocks in frame P and frame P minus 1, and by averaging this SAD values in entire frame, we calculate the temporal feature. Here you can see a heat map of our spatial complexity feature, also our temporal complexity feature on the left image, left side. So there you can see heat map for the spatial complexity, and also on the right image you can see heat map for the temporal complexity. For example, in this area that there are some hair movement, you can easily see that we have some temporal activity here. But about the experimental results, the main advantages that VCA has is it's about its speed performance compared to SITI. As I mentioned, SITI is only 5 frames per second, but having CMD optimization, also multi-threading, we can reach around 400 frames per second feature extraction, which can be used for live streaming optimization. So even without multi-threading, you can see that when threads is 1, we are still much faster than SITI. But with very regular CPUs, with 8 threads, we can reach up to 400 FPS for 4K videos. So to calculate the correlation, we encode 500 video sequences, all in tera mode, and then we calculate their bitrate, and we calculate the correlation between the spatial complexity features, the state-of-the-art SI, and our spatial complexity for 2 codecs, X264 and X265. And we can see that the correlation for E, or the proposed spatial complexity, is much higher than SI. So this seems that can be predict the spatial complexity of the video much better than SI. We also do intercoding using low delay picture configuration of X265 with different presets, very slow, medium, and ultra fast, and still we can see that E performs better than SI, and in most cases H, or our temporal complexity feature, works better than TI. So we also calculate the correlation with encoding time complexity. You can see that H performs better than TI, but for E and SI the performance is not that good. It shows that temporal complexity has much higher correlation with encoding time. But one very interesting observation, because Werner, I think, discussed this on Monday, that the correlation across multiple resolution is not good for SI. They have their own reasons. But fortunately, for our spatial complexity feature, it's not the case. So you can see that, for example, between 720p and 1080p, we have almost 100% correlation, which means that we can calculate this spatial complexity feature at low resolution and even speed up the process of the feature extraction to around 1,500 frames per second. So which application we are using? We use quite in some applications this features. One of the first application that we use is for shot detection. We know that shot-based encoding can improve the encoding performance. So we introduce epsilon as the gradient of the temporal complexity. So we can see in the places that we have peak values, we can consider as shot boundaries, and we could successfully predict shot boundaries in the video sequences using this temporal complexity feature. The other application that we use is in online per title encoding. We know that in live streaming, usually a fixed bitrate ladder is used. It's fixed bitrate resolution pairs are used in order to avoid adding any additional latency. If we want to optimize this bitrate ladder per title, so we are going to add some latencies. But by extracting some features, E and H, using the VCA, we could optimize our bitrate ladder per title, because we are not adding that much latency to optimize our bitrate ladder. So as you can see in this workflow, we first analyze the complexity of video, then we select we determine the sync cuts, and then we adjust our bitrate ladder based on the content. So based on the type of the content, if we have a middle complex, simple complex, or very complex video sequence, we can have different bitrate resolution pairs. And here we can give one example for this content. We encode the same video content at 1.6 megabit per second, one for standard profile or fixed bitrate ladder, second using our online per title encoding. And here you can easily see that our per title encoding can improve the quality, because it selects the optimized resolution for this content instead of using the fixed resolution, which is 540p for fixed bitrate ladder. But our online per title encoding can predict 1080p as the optimized one, and we can see the result here. So as a conclusion, VCA is a fast preprocessor, determines the video complexity features. So it's independent of all the codecs that we are using. So this feature shows higher correlation with encoding time, also encoding bitrate, and it can aid encoding process in the video applications. So this is open source software. If you are interested, so please have a look. Also, we encourage you to contribute to this project, and we will be happy to get your feedback.